So this video is going to take you through a process called binomial theorem, where you can expand binomials that are raised to higher exponents than, say, squared or cubed, without having to do all of the multiplying out. Still a slightly tedious process, but will take less time. So our first option for getting the coefficients that we're going to use is called Pascal's triangle. And the way Pascal's triangle works, you start with a 1 on top. That does not count as really your first row. That's like our 0th row, and then we're going to have another row with 2 1s in it. So the first row would be saying a plus b to the 0, which would be 1. And then the second row, a plus b to the first, which makes sense. That would just be 1a, 1b. The next row, we're going to do 1, 2, 1. This 2 comes from adding the numbers up top. They kind of make a triangle. So there's lots of triangles within the bigger triangle. This will form a big triangle, but each little triangle here shows us how to add to get that number down below. These would be the coefficients of a plus b squared, hence the 2 here. And then you kind of keep going. 1 plus 1 is 3. Sorry, 1 plus 2 is 3. 2 plus 1 is 3, and then we get 1. That's your a plus b cubed. And so on. I'm going to add a couple more rows. 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20. Now the writing out of Pascal's triangle itself, once you get to higher rows, can be a tedious process that you might want to use our second option for when we take a look at it. I'm going to give you a preview of where that will go. So each of these rows that has the different exponent numbers in them, so the first one has the 2, then 3, 4, 5, 6, and so on, that matches up with your exponents here. I'm just going to put a dot, 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 because you can keep going with this. Now, if I pick one of my rows, and we think about it in terms of like 0, 1, 2, 3, 4, 5. You can also see that that row has technically 5 things in it that we're going to be expanding, although we have the 6th term because of that 0th term. So let's take a look at row 5. I'm going to use the combinations. So I'm going to do 5C2, which technically would go with this number here. This combinations will give you all of these same numbers in these rows depending on the spot that you're looking at. So if I go to my calculator and I type in 5, you're going to go to math, go over to PRB, and then select combination, so 5C2. That does give us the 10 that's in this spot. So that's 0, 1, 2, 3, 4, 5. So you can start with 5C0, 5C1, 5C2, 5C3, 4, and 5, up to the same number that's over here. We're going to kind of save that for later, but I just wanted to show that the combinations would be another way to come up with these numbers without writing out this entire triangle if you just wanted a specific row. So we're going to expand using Pascal's triangle before we actually introduce the true binomial theorem. So we're going to take an easy one to start with, 3x plus 4 to the 5th. So a couple things that are important here. The 5 up top means we're going to be using the row with 5 in it. These take a lot of space horizontally, especially since there are 6 terms that are happening here. And in addition, our exponents will always need to add to 5. Okay, so we're going to start off with our first term. We're going to use the first coefficient times 3x to the highest exponent of 5 times 4 to the 0, because we have 5 there. These need to add up to the 5 that we have up top. And then we're going to go to our next one, and we're going to change up the exponents by going down 1 and up 1. So 3x to the 4th, 4 to the 1st. Again, making sure those add to 5, but that's going to change. The first number is going to go down, the second number is going to go up by 1. Plus, 10, 3x cubed, 4 squared, plus another 10. So you see there's a lot of space getting taken up. I probably am even going to run out of space, just run out of space. And there are ways, once we do this first example, that I can show you to decrease the space a little bit that you're using. Now I literally ran out of space for just my last term. Now the first and last terms, since you have that 1 to the 0 exponent, you technically, if you realize that every time, don't need to write that in. So that could save you a little bit of your horizontal room. And this one, same thing, 3x to the 0. We know that's going to be 1. So you don't really need to write that. You can just write the 4 to the 5th. Okay, then once you're at this step, you're going to want to do your calculating. So the best thing that I can tell you, advice I can give you for this, is plug into the calculator. I mean, I don't need to for this, but the coefficient times 3 to the 5th times 4 to the 0, if you need to. So in future ones. Here I'm really just doing 3 to the 5th. So 243x to the 5th. And you can worry about the exponents after the fact. And then the next one, I would do 5 times 3 to the 4th times 4. So really just plug in all the numbers, taking the variables away so you get the correct coefficient. So 1620. I'm not going to do all of these in the calculator. I will let you kind of work through that. But next one you would do 10 times 3 cubed times 4 squared. And you just have to make sure you're very meticulous when you are plugging this stuff in or doing simplifying that maybe you can't plug it all into the calculator at once. So this would be your final result answer. All right, so that's one option, and since I was going to only do one video, since this video is getting a little bit long, I'm going to pause there. We're going to do a second video for the binomial theorem and for finding a specific term. But it's essentially the same process as this. It's just finding the stuff that we have here in green. We're going to do a different way.